Right, hey everybody, last talk. I promise I won't go on forever. We've all got wives and kids to get back to and all of that. I've gone for a really nice subtle one. Why Kafka and Iceberg will define the next decade of data infrastructure. I always go big or go home, so it's going to be quiet. The good news is I can answer that question in the first 5 slides, and the rest of it's just really cool stuff that we can dig into and a couple of demos. In terms of demos, how fast I talk will determine whether you get to see a demo or not. And I promise it's a demo you've never seen before, so you want to see it. So make me talk faster. So we can't really talk about the future of data infrastructure without talking about the past. To know where we're going, we need to know where we came from. And in Kafka's case, that's starting from our mess of apps and databases and SASes and all sorts of things. Thanks, Confluent, for these diagrams. I stole them, by the way. Going from all of that to a really nice unified Kafka. I've done many of these. It's wonderful. It's great. I think we're all here because it's wonderful and great, and we've all seen the benefits of going through that process. The thing is, though, we kind of did that on this side. There is still, and I will fight anybody who wants to disagree with me on this one, this same point-to-point, the same messy, disconnected applications still exists on the analytical side. And I'm talking about 3 letters that I'm going to sort of spit on the floor as I say them as I go through this talk. I'm talking about ETL here. So I feel like we've put the last decade, certainly in my life, into solving things and making them all nice and unified around Kafka on the operational side. On the analytical side, we've kind of gone, yeah, more ETL. Well, let's just throw some more pipelines at it. What could go wrong? So what we really need is a way to, we need something to jump in and do the same job that Kafka did to the operational estate to your analytical estate. And in my opinion, that is open table formats in general. And because it won the open table format war, that is Iceberg. All we need really is a standard, and it doesn't just, by the way, I'm not even a huge Iceberg fan. It's just that Iceberg won. We can go on all night about the features of Delta and Hudi that are better. I agree, but Iceberg won, so we have to get over it and use that and swallow it. Right. So I told you I'd be done in 3 slides. I'm now presenting to you a world where our operational estate is beautifully unified around Kafka, and our analytical estate is beautifully unified around Iceberg. In that case, adopting new data sets, adopting new applications is just a case of aligning around one of these standards. Fantastic, right? You've probably all seen the glitch. There's still we're so very, very close, and yet there's still one piece missing. The bit in the middle. Somehow, we've got to get from Kafka to Iceberg. That's the easiest way to do that. You're not allowed to say it. 3 letters are banned from the rest. ETL, of course, we could just do that. We could just ETL directly from Kafka to Iceberg. But I feel like that's a missed opportunity. While we're reinventing the world according to what's in my head, why don't we go the whole hog and see if we can do something better than just having a nice little pipeline sat between our Kafka and Iceberg. Before we do that, though, let's go really back to basics and ask what is a stream. We have our continuous flow of small packets of data, usually processed in real time as it arrives. Works great with Kafka. I can shorten that definition down to Iceberg's worst nightmare. That's entirely the opposite of what Iceberg wants to see. Streaming's optimized for row-based data storage. Iceberg or batch processors are optimized for column-based storage. Streaming's looking at push queries or dealing iteratively in time as new data comes in. Iceberg's optimized for very large volume queries where you send it off and wait a while, and that's okay because it's working on a lot of data. We're looking for small incremental ingest on the streaming side, or we're looking for large batch ingest on the Iceberg side, and relatively, always have to say relatively short retention on the streaming side, orders of days. Relatively large retention on the Iceberg side, orders of years. So if you had to design 2 systems or 2 formats or protocols, I'm just going to use those interchangeably for a bit, that were designed so perfectly to not work with each other, that's what you come up with. Iceberg and Kafka. So bridging the gap is going to be really, really hard. And I've already mentioned that you could do it with ETL. Kafka Connect is probably the best ETL system I've ever seen in my life. And there is an Iceberg connector. You can go download it from the Apache site right now. It drops straight in. And it basically does a bit of this. What it'll do is it'll buffer some records out to Kafka. Every now and again, it'll write them out to your Iceberg, and it will even do some metadata updates to make sure it's available to your processing engines. And it works until it doesn't. Everybody I've spoken to that's used the Iceberg connector has said, well, that was fun, but I then spent a lot of it did work eventually, but I spent a lot of my life tuning it, and we now can't change anything. So, and that really is the crux of it, because these two systems are so disparate and the way in which they're used to interacting with data is so different, it's very, very hard to create a pipeline that can universally address the problems of one system and apply them to another. It's a very, very new topic, and I'm not necessarily talking about it tonight, but the same problem exists the other way as well. If you want to get your Iceberg into Kafka, you've got the same kind of things to deal with, but just the other way around. So a few things that you're going to have problems with when you start doing your ETL pipelines. First things first, let's do the obvious elephant in the room. When you're ETLing, it is by definition a copy of the data. So if you're paying for storage in Kafka, you're now paying for storage in Iceberg too. Storage is really cheap, so it's not necessarily a big thing until you get to a very large scale when it becomes a very big deal. But this second one is a big deal. You end up with a high latency. Do you remember how I said we had to buffer things on the Kafka Connect side because just throwing one message at a time in Iceberg makes it blow up really, really fast? Just an aside to explain why that happens. If you throw one message, the worst case scenario of throwing messages at Iceberg creates one snapshot, one data file, lots of other pieces of metadata per message that you go. So if you're doing, I don't know, 10 million messages an hour, that's not a large amount for Kafka. You're going to blow up your Iceberg metadata really, really fast. So we don't do that. We buffer them into bigger chunks to make sure that that doesn't happen. But when we do that, we introduce a lag. That the time it takes to buffer messages is how far behind your Iceberg table is when you're trying to read data. So what you've got is an inconsistent view of the operational world of your data for your Kafka clients and the analytical world of your data for your Iceberg clients. We don't want this. This sucks. And you finally got my personal favorite. This is my personal favorite that just gets glossed over way too much. ETL, by definition, is the equivalent of me sort of, if I need some data, picking up my phone and just chucking it over the wall over there, right? All I care about is that it gets over the wall. I don't care at all about what's on the other side, and what's on the other side is in no way linked with me. So, Addy's mentioned schemas earlier tonight. If I have a schema defined on the Kafka side of my business, there's nothing that says it has to be enforced on the other side of the world. And it's just an ETL. We're just a data transfer pipe. Right? And when something changes on my side, it doesn't change on the other one. I'll give you a really great example. I promised I wouldn't talk too much, but I'll give you a really great example of this one. I was talking to a guy the other day. He had a Python application that was sending stuff through Kafka, and they had it was like customer tracking, and they had offer shown, Boolean field, saying true, false. Well, absolutely wonderful. Throw it over, it seems in the database. A few weeks later, they go, why aren't we showing anybody any offers anymore? No one, like, our recommendation engine must be completely broken because we're not showing anything. What had happened is on the Kafka side, the schema had evolved, so it actually gives you an ID of the offer shown. Of course, on the analytical side, it doesn't do that. It just evaluates anything non-zero to false. Automatically converts the schema, completely blind, and there you go. Suddenly, we're getting a completely misrepresentation of what's actually happening on our analytical side. So I think we can do better. I think we can unify the way in which we govern our data across both sides of the divide. And there's some non-funcs as well. You have a lot of maintenance, a lot of storage. A blurred ownership. This is also a really good one. Connectors and ETL pipelines are developed by people that have no stake in the data they're moving. And you've got low discoverability. That's because in order to create an ETL pipeline, someone's got to go, I need that data, and they've first got to find out that that data exists somewhere to do it. So now we get to the good bit. Let's see if we can fix that. What will we look for if we were going to go and create an entirely new architecture that solves both of these problems and unifies everything on both sides of those divide? We'd look for really cheap long-term retention. We'd look for a single source of truth. I want to land my data once, and I want it to be available operationally and analytically without copying it. Second I copy it, I've got the possibility of inconsistency. I want really fast access. I need to update these slides actually because I want sub 100 millisecond access, but I also want really, really high volume slow access as well. That's a really important, because we talk in Kafka terms of going fast, but as soon as we start ballooning out volumes, it's no good if it's completely useless on the analytical side. And I mentioned before, we want easy evolution. We want to be able to change things at one end and see those changes instantly reflected at the other end. So how do we do it? Well, I'm about 14 years too late, unfortunately. Nathan Mars pretty much nailed this back in 2011. Anybody, hands up for Lambda architecture fans? 2. It's more than I normally get. I'm all right with that. So for those that don't know this, back in the old big data days, I was working on Hadoop and Hive back then. We had this kind of architecture. The idea was that you had a slow, high-volume data storage, your batch layer, which in those days was Hive. And you had a real-time layer, your speed layer, which in those days would be something like Storm or Samza, now probably Kafka. And you would have a combination of the two in order to solve your applications. So if you had a purely analytical application, it's great, it can read from the batch layer. If you had a purely real-time application, it's great, it can come from the speed layer. The real power comes here, when you can see a completely unified view of your data all the way from back to the beginning of time, all the way to right now, this very millisecond. The problem is, the reason only 2 hands went up, by the way, is this really powerful bit is really freaking hard. What you ended up with was having to design a set of applications that were capable of understanding all the concepts that came from the batch layer, all the concepts that came from the speed layer, and mixing them together in a way that was really nice and efficient. Any Apache Beam fans? No, damn. No, so Beam did a fairly good job at this, but it was hard, like very, very hard. And today we very rarely see pure lambdas. Could argue we very rarely see pure kappas as well, but we'll stick with lambdas today. So this got me thinking, and it got me asking a really basic question. What if everything was just Iceberg at this point? What if we were able to take these concepts of batch and speed layer that I've now hastily swapped out to say hot set and cold set. I've done that on purpose, hoodwinked you there. And what if we were able to represent both this hot set and cold set together just purely as Iceberg? Suddenly, this bit where all the real power exists isn't so difficult to do anymore. You have a nice, easy standard that you can connect your applications into. At that point, everyone likes a bit of SQL. So let's have a look at a SQL application that was mixing real-time and batch with our fancy new architecture. Really, it just becomes like select star from speed, union all batch. It's that simple. Now, if we get to the demo, I will show you that a bit later. Much, much easier than having to worry about all the concepts that come along with the speed layer or that come along with the batch layer. So this could be anything, but it happens to say stream-based on it. It's funny that. What you really need is some kind of service that can mix a hot set stored in Kafka and a cold set stored in Iceberg, and consider them all to be Iceberg for the purposes of clients. Let's just have a quick check and see whether we've achieved our goals if we've done this. So the first one and the big one was we didn't want any lag. We want to be able to see a complete data set right from the beginning. And we have achieved that. We can access everything up to like the now point, all the way back to our long-term storage, and it just looks exactly the same to our Spark, our Trino, or our Dremio, or whatever we want to point to it. Have we achieved our cost-efficient storage? Well, yes. We no longer have any copies of the data. As we hit the retention limit in Kafka, we seamlessly cross over into very nice and cheap object storage for Iceberg. And what about our maintenance? If we're going to blast messages as fast as we can at this thing, are we going to end up with a huge maintenance overhead? Well, there's another slide about this coming. No, we're not, but there's another piece that needs to happen to make that happen. So if we were to have, if you squint a little bit and look at this sideways, I've just redrawn our diagram that has ETL in the middle of it, right? I've just made the gap smaller, right? So that's not what our intention is. And if you did that, we haven't saved anything on maintenance. So we need to find a way of representing that hot set as Iceberg, but without doing any data movement or data transfer to do that. And I'm going to borrow something from a few tips from the database world. What if it was a view? What if the data stayed in Kafka? And what if we use protocol translation or just at query time translation in order to be able to represent all of that data, Kafka data, still stored in Kafka as if it was in Iceberg? So the principles of the view are simple. We don't do anything in the background. There's no async processing, there's no async transfer or anything like that. What we do is we wait for an Iceberg query to come in. When it does, our intermediate service calculates what information it needs from Kafka and goes and fetches it from Kafka at that point and serves it back. If anybody wants to talk about the balance between extra computation versus async computation after the event, great idea. We can do that for hours, but not now. Right. For now, what we end up with is this Iceberg view of our Kafka data that solves our problem. It's always up to date because we're essentially a consumer at this point. We're reading from Kafka back into Iceberg. We're reading the very, very latest data as if we were a consumer. We have our single copy of the data. It's in Kafka. And here's the fun bit. We've also solved our governance problem. As a function of being able to do this conversion, we have to be able to apply Kafka schemas as Iceberg. Right? That's implicit in this flow. And once you have Kafka schemas as Iceberg, I'm going to show you later, they stay as Iceberg as the data transitions from hot set to cold set. So what we've done is we've kind of flipped the scripts a little bit. We've ended up with a Kafka first world where we swallow the whole Kafka ecosystem and we transfer it all the way across to the right of your architecture diagram into the analytical world. This one really excites me. That's the governance potentials are amazing. And it's not just, we only talk about schemas, but it's not just schemas. It's ACLs, it's RBAC, it's all of the great, it's even down to telemetry and lineage. It's all of the great stuff that we can now do on Kafka, moves into the analytical world seamlessly. I promised my principal engineer I'll put some technical stuff in. Anybody wants a nap and isn't interested in the technical stuff, you don't need to. So this is the how. We've done the cool stuff now. This is the how we achieve it. And the easy way to do it is to just start thinking that everything is JBob. Not that JBob, a different JBob. We start thinking of Kafka in kind of the way I like to think of it, the way it was originally. Kafka is just a bunch of bytes. And once you start thinking of Kafka as storage of bytes with no particular anything extra added on top, you start seeing it has some kind of really good characters that we want for this kind of view approach. If you think about it, Kafka has a very efficient sequential read. Wouldn't work if it didn't. It has concept of organization. We have topics, we have events, we have topic table duality stuff as well, so that really helps with this stuff. We have some indexing, not enough in my opinion, but we do have some. And we have some kind of sharding. every time I do this talk, somebody goes, oh, partitions in Kafka are like partitions in Iceberg. No, not at all. Partitions in Kafka are purely there for concurrency. Partitions in Iceberg are there to help query efficiency. They're there for pruning out data that you don't need for your query. So it is not a one-to-one map and never will be. And there are quite a few of these Kafka to Iceberg solutions. That's the problem that needs solving. That's where the interesting stuff is happening. But if you have that, we can start replacing our Iceberg layers. Everybody's seen this picture before, right? That's how Iceberg is built, the 3 layers, the catalog, the metadata layer, and the data layer. But we can start rebuilding them as if they didn't exist. So today, your Iceberg catalog, let's face it, is a REST catalog. You still need this, but it was an external component already, and it stays an external component. This metadata layer is all file-based today. It's metadata files, manifest lists, manifest files, and you can just make them ephemeral. So what we do at Streambased is we create an S3 compatible file system. So it just implements the Amazon S3 HTTP API, and we interpret the request as if it was a request from an Iceberg client, and we serve it back what looks like a file. It's not really a file, it's really metadata that we discovered from Kafka. And then finally, we have a set of data files down here that you need to serve. Again, these are ephemeral just like the metadata, and we serve those over S3 just like we would the metadata as well. One quick gripe on my side. Avro is was a first-class citizen of Iceberg. Iceberg was founded with 3 file format support: Parquet, RC, and Avro. Really, everybody's forgotten that, and people only care about Parquet anymore. But if you wanted to stick with Avro, you can interoperate with Kafka really, really well. So the quick flow diagram. We take our Spark, Trino, Dremio, DocDB, all work exactly the same way. First thing they're going to do is go and fetch a whole load of table metadata. We're going to transfer. We're doing protocol translation here, really. So we're going to translate that into a request for Kafka metadata. This is where we start looking at our topic names, shapes, things, schemas, things that we need. We're then going to present a bunch of manifests to say where the data is. Again, we've built this off Kafka metadata, so the data is where we say it is, and we discover where we're going to say it is at query time. And then finally, the engines are going to go and fetch some data. And that data, again, is translated into a consumer fetch. So we are literally fetching the data from Kafka as we need to serve it to the applications. And that's some good things about it that I think I've already covered, so we'll skip that. Last slide before demo, I think. So we're motored through that one. One of the, I said I'd circle back to seamless transitions from hot set to cold set and things like that. And I'd address how we solve the Iceberg maintenance problem. This is it. All you've ended up with is an accumulated cold set and hot set that you're presenting to both your Kafka clients or your Iceberg clients as if it was one. When you add new data to it, the only thing that happens today is that the hot set starts growing. And it grows and grows. But our hot set's a view, so that's fine. We still have full up-to-date access to our data. It's all wonderful until it continues to grow and starts getting uncontrollable. I do not recommend storing everything in Kafka until the beginning of time and then representing it as Iceberg. Some bad things happen. There's a reason we had an object storage-based file format for designed in Iceberg. So what you're going to want to do is set a limit at which point this hot set becomes too large. This is arbitrary, tunable, also very, very elastic if it needs to be. And at that point, what you can do is just take it, at that point, this is an Iceberg table, and this, for all intents and purposes, because of the view, is an Iceberg table. So transitioning from the hot set to the cold set becomes insert into batch, select star from speed, or insert into cold, select star from hot. Damn, I need to change that. So it's a process that your Iceberg client knows exactly how to do, And you can just set it on a continuous loop based on this threshold. The second you've done that, by the way, you moved everything out of your hot set, clean it up in Kafka, go small again, and you start adding data again. Nice and simple. So you run this on a continuous, but the reason you don't have the maintenance problems is because this transition here, this is what Iceberg likes, right? This is a big, large chunk of data that we're going to insert. Right? This is its favorite thing. We're not blasting one message at a time, loads of times at it. We're doing a big, chunky insert. And what's even better about this is it's an atomic operation that happens in the background. So you don't actually need to update your tier point, this point where it moves, until you're absolutely sure that transition's completed. So there's no zero downtime while you're doing this. At this point, you have full view of the hot set and cold set. At this point, you have full view of the hot set and cold set. And at this point, you have full view of the hot set and cold set. And your applications will never even know that this kind of background transitioning is happening. So, demo time. Do I have time? Did I make it? Where's Sean? Yeah? Nice! Good. Thanks. Right. It's all running, so we'll do this really, really fast. So, that transition process is what I'm going to show you here. I haven't got a nice chunk of Iceberg data to work with right now. So what I've done instead is I'm going to start in the middle. Let's imagine that this transactions old topic represents my very, very large hot set. It's grown too big, and I need this to transition to cold. It's got 500K messages on it right now. And what I want to do is get that into the cold set, and then I want to build a hot set and cold set view that is the combination of transactions old that has just gone in the cold set, plus these new transactions. And if I refresh, I'm going to do this very fast, you can see these new transactions, the number count is going up. This is a real topic. This is it's being written to. The number is going up. Huh? So I'm going to do this completely from, he says, I'm going to do this completely from Spark. I like Spark, but you could use any Iceberg engine. The important point is we're not going to go near Kafka to do any of this. We're going to do this all from Iceberg. So the first thing I'm going to do is show some tables. And what you see is we've already introduced our universal governance because those tables perfectly match the topics that you just saw in Kafka. If I was to go and describe one, guess what? This is being driven by schema registry on the Kafka side. This is not a separate schema, and it's nicely linked to the whole thing. And then again, guess what? If I want to run this, if I want to do a count, I'm going to see my 500K records. What we missed at the beginning, by the way, is the namespace that I used, ISK. Whenever you see this ISK dot, that's the view in this demo, okay? So all of this is being solved by a view running directly on Kafka. You're going to see another namespace in a minute that represents the cold set, which is the physically stored data. So let's do our transformation. So I'm going to use CTAS to do this. MinIO, by the way, is my long-term storage. MinIO, for all of you guys who haven't encountered it, is a local running object store that mimics S3. So these are actual real files now. And we're going to fill those real files by going create transactions table as Iceberg. Forget the partitioning, that's for another talk. And we're going to do it as select star. So one simple action, you will be able to see that all of the data has been fetched from Kafka and written into Iceberg. And that was done by our Spark Iceberg engine with nothing fancy. And I'm a very untrusting person, so if you don't believe me, data, transactions, here we go. Here are all the files. There's Parquet files sitting in MinIO now, and they exist. And just in case you completely don't believe me, I'm now going to delete it from Kafka. So there is no record of transactions old anywhere in Kafka. So what have we got now? We've got our hot set, which is the transactions topic here, which is being written to consistently. And we've got our cold set, which is the 500K records that we just transferred into MinIO. So if I go back to my Spark, what I can do now, well, first I can show you 500k transactions just went into min.io. Yeah, fine. And I can also show you that hotset has about nearly 2k records in it. What do you think the answer to what do you think this query is going to produce? Shout, can't hear you. Sorry?
The 3,000.
Just the 3,000? You sure? Do you want to have a second chance? Go on, Nicoletta.
The whole set, where it's all got a unit for 500k.
There you go, 500k plus the 3,000, because we're selecting from a union. We've unioned the view with the hot and cold set. So if we were to run that, there you go, roughly just a few over 5,000. So, but the important part is from the Iceberg client, it sees no difference. This is where it doesn't matter whether it comes from Kafka or not. You wouldn't know if you're working in Spark right now. And just to prove that this is real time, I will go ahead and run that exact same thing again, and you can see it's got bigger because we've written more data in it. I know you have to trust me on this one because I can't prove it to you, but there are no background pipelines. There's no ETL going on behind this. This is just views. And once you have this principle, this is just a little fun query to end. Once you have this principle, you can apply any kind of operation that Iceberg is capable of doing, even some fancy queries with some joins and some groupings in them, onto that unified set. That's the demo. That was the really exciting bit. So, nearly pub time, I promise. What have we achieved? Well, we've taken the two de facto standards. I don't know why I put de facto in. They are the standards. If you're going to be working with real time, you're going to be working with Kafka. If you're going to be working with large volume analytical data, you're going to be working with Iceberg. We've unified them all together so that they use a single source of truth for data. They use no duplicate copies, and they unify the governance between them. And we created a layer that's both real-time and durable. It's simple, it's cheap, you get the richer speed and batch applications, and the single source of truth. In other words, we've delivered on the original promise that Nathan Mars tried to do so long ago. Thanks very much. Before we go to that, thank you very much. I have two bonus slides for you to take home and start thinking about. First one, you probably saw it earlier for the eagle-eyed of you. We said, what if everything was Iceberg? What if everything was Kafka? That's the thought to take home with you as well. What if we could unify an Iceberg set, and a cold set, and a Kafka hot set, and apply them both as if they were Kafka? And that would create something that looks a little bit like that, which, in my opinion, would be pretty cool. Thanks very much. Stay in touch.
Is there any questions? I can run on with the mic. Yeah.
Hi, thanks. Is there a reason you bubble the two tables up to the client and not encapsulate them as a single table? Then you wouldn't need to do the union client side like you could do internally, right?
Absolutely. It makes a much better demo. In production, you're absolutely right. We have a nice little box that sits. Right here. That should take care of all of that stuff. Really, the only tweakable knob we should give you is the tiering point, the retention point. You're going to do a lot of running, sure.
On last demo, on last demo slides, are you implementing some sort of tiered storage using Iceberg as a second tier?
I was really hoping someone wasn't going to ask me that. Yes and no. So that's, are you re-implementing tiered storage for Kafka? Yes and no. So yes, we are, but we're trying to break the link with Kafka. Tiered storage today is embedded inside the broker and very, very coupled with the way in which Kafka operates. As you can imagine, we are talking about the P word that I'm not supposed to say, the proxy layers that sit across here, at the top here, in order to be able to achieve that on top of basically anything. We've chosen Kafka and Iceberg because there's the standards here. Could be anything.
What are the prerequisites for running this? You mentioned scheme registry, that's clearly a prereq. Would it work with any Kafka? Would it work with AWS and Scope, for example?
It sure will. So we're protocol translation, so anything that speaks the Kafka admin client and consumer protocols, done. That's it. Yeah, I forgot what the other question was. Oh, no, the ecosystem dependencies. Right now, we're building purely for Confluence Schema Registry, but there's no reason you couldn't substitute that out for Glue or other other things like that. But you do need to impose some kind of governance somewhere, and then it gets flowed both ways. So what's kind of interesting is if you decide to impose the governance on this side, but we can talk about that at length.
Will it work with Zookeeper and KRAF, or only for you?
No, yeah, Zookeeper, KRAF, no problem.
Yes, I've got two questions actually. So the first one, so you were talking about Avro being something that's still a support formats like this. Avro is kind of a road-based structure, it's the Parquet is a column. So in terms of Kafka, when you're streaming back, sometimes you will stream back from the beginning of time. Occasionally speaking, sometimes that happens, right? So when you're streaming back, would it be better with a row-based structure, Avro, or with Iceberg and Parquet?
This is a really, really deep and awesome subject, but to do it in the 2 minutes, because we all need to get to the pub. Row-based strategy formats work better here. Column-based formats work better here. The ideal solution is what we showed in the demo, which is a union of Iceberg working as Avro here and Iceberg working on Parquet here. Unfortunately, most of the big players in the world, Snowflake, do not support this and are linked to Parquet only. So I showed you Avro in the demo, but we do actually make my principal engineer not sleep very often, and he's worked out Parquet-based solutions. But there are a bunch of trade-offs that come with all of these. And it's a really great talk that I should write sometime.
And the second question is, at the beginning of the talk, you mentioned that Iceberg is not necessarily the choice that you go for. What is your choice for this data solution?
So I'm the wrong guy to ask, definitely the wrong guy to ask, because I'm a Kafka guy primarily. I used to do a lot of Hive, haven't really been deep into the formats, but around the office, the word is Hoodie's the king. Hoodie's amazing. Go on, Tom.
Okay, you show transactions. It's a handle on the data, so it's easy. What would change if it's customer data? So we need to actually kind of this layer, where we do the tiering. It should be some ETL or something like preparing the data can be queried in Iceberg in some kind of a nicer way than CDC data to be duplicated, all of this. So can you share any thoughts about this?
Yeah, it's the inconvenient part of it. Yes, so you're talking about compaction and materialization, those kind of things where we want, say, latest key, or we want something. You don't just want a table that contains every single event ever. You want to roll it up. Now, you've got a few choices here. You can do it downstream. There's no reason to say this isn't ultra bronze or the far left side of your data and there are future flows. But that's a cop-out, right? I've just added more ETL. However, there are very, very complicated ways to solve the union between these two. Solving it here is easy. Iceberg gives you a nice, easy way to solve it here. Solving it here is actually quite easy as well. You need some sort of basic index on the top to track the latest values. Solving the two of them is a lot harder. I don't have a good solution for that right now. Yes.